a workshop session as opposed to a panel style session. So the idea is that we have a presentation prepared, but you can ask myself or the other speakers questions at any time, and we'll try our best to answer your questions, or we can even have discussion among participants as well, which will enable it to be a lot more dynamic and interesting. So the topic of this session is that I'm not sure. I just need to make a start so we can cover everything, but it maybe we'll try and solve it. So just to start out, we'll just introduce. I might just get myself and the other two workshop organisers to introduce themselves. So, Sam. Oh, okay. I'll start. My name is Bronwyn. I'm a student here at UTS. I also work in cybersecurity, and I've been involved in the internet governance space for about 2 years, starting off with a fellowship to the Internet Governance Forum in 2017. So I'm fairly new. As a newcomer myself, I hope I can sort of share some of my experiences as a newcomer and help people to find out more about this space.
Hi, I'm Sam Dickinson. That's from my Twitter account, Observer. I go to a lot of meetings. I try to be as neutral as possible because what I try and do is explain to people in simple words what's happening in internet governance policy decision making. So that's me.
Hi, my name's Bruce. I'm here from the .au domain administrator, and I've been involved with the internet in Australia for quite a while.
Thank you. So Sam's going to start out. Well, I'll just give a quick overview of this session, what we're going to be covering. So this session is, it tries to not assume too much knowledge. So we will start with the foundations of a bit of history about the internet, how the internet works, and internet governance, so which is more about how decisions are made, how are policies made on the internet, and who is involved in this space. And then at the end, Bruce will finish up with a bit of insight into what internet governance looks like in Australia. So I'm going to hand over to Sam now, and she will talk a bit more about the history of the internet. And I would just like to remind you that this is a workshop, so feel free, if you have any questions at any time, to raise your hand, and we have another microphone here, so we can come and get your question.
Right, so is the microphone working now? It is? Fantastic. Okay, I've never given a presentation in the round before, so this is going to be fun. But I don't know if anyone's noticed, I've got an almost round swirly skirt, so I might take advantage of this. Right. So the internet has an interesting start. Now, a lot of people, there is a myth going around that the internet started because it was supposed to survive nuclear attack. That's a myth. If you go back to the start, the kernel of where the internet idea began, it actually began when Russia launched the Sputnik satellite. Not the internet itself, but the launch of the Sputnik satellite meant that the American government went, oh dear, someone is taking technology further than us, so they developed the Advanced Research Projects Agency. So because that developed, that then allowed the creation of what was then the ARPANET that we now know today as the internet. So that was the organisational framework that allowed the internet to develop. Back in '61, Leonard Kleinrock wrote a paper about packet switching. So that was the concept with like a telephone system. Do people know this stuff? If you know about packet switching, I'm not going to talk about this. No, people are looking a bit blank. So the concept, sorry? Okay. Okay. Before packet switching, everything was a direct connection. So if you had a telephone call, you had to have that line full time. The concept with packet switching basically just allowed you to share time, that you would send packets and more than one person could use that line. Yep. I'm going to rush through this so we can get into more important stuff. You can read the slide. What I love about the internet and the concept of networking was that Robert Taylor, his laziness helped to develop the internet because he didn't want to have to go to 3 different terminals to sign into different networks. He wanted to be able to sit there and not zoom across the room to different terminals to access other computer networks. He wanted one. Therefore, ARPANET eventually was created. So basically, the internet was created because there was a technology war with Russia, people were lazy, people wanted to communicate. So internet governance really was not a term until 2004, 2005. But what was known as what we call internet governance now would have been considered technical management, technical administration. And the first example of that was when Steve Crocker, at his girlfriend's parents' house, wanted to write a document saying, hey, to the community of internet developers, well, you know, his friends basically, how can we discuss the issues about developing the internet? Which he called a request for comment. He was at his girlfriend's parents' house, people were asleep in the middle of the night, so the only place he could go and write this was the bathroom floor. So the internet's governance system began on a bathroom floor. The interesting thing is that the RFCs are an interesting example of how internet governance changes. So the original idea of an RFC was that it was a fluid conversation, you know, that you would issue a document, like you kind of on a social media channel today. You'd post something to Twitter, someone else would reply to it, you know, and you just have a multiple series of tweets. They've kind of ossified these RFCs into the final documents. So before an RFC, you now have an internet draft. And they're the conversation. And if you're really, really lucky, the technology that has become an RFC eventually becomes a standard. There aren't many internet standards. No, wrong way. And I love this. So for people who now look at the internet and think it's this amazing, powerful system that, you know, must have had some sort of direction. No, it didn't. Back at the start, it was a bunch of grad students hoping an adult will walk into the room and help them know what to do. But they weren't. They were grad students. They developed what it was. And so that means that even today, anyone can participate. It was a system designed from the bottom up, and that still informs its ethos today. So what could you do on the early ARPANET? Well, not much. Unless you're a geek, you really didn't want to access it because everything was command line. So you could telnet into systems, you could transfer files, so kind of like Dropbox, or you could kind of do email. But email didn't even come around until 1971. And then there was Usenet, which is still around, and was like a very early form of social media, but only if you could use a command line. So this is the first network, and this is a geeky joke. So the first the first login to the system, they were trying to log in. They typed in LO, and then it died. So successful start to the internet. A little bit later, that's what the internet looked like. You could map it with a pen and paper and map it physically on a map. But now it's kind of hard. These are 2 attempts to do it, but you know it's just so big now that you cannot map it. The interesting thing in regards to how governance has become harder as the internet has developed is, as we saw, if I just go back, we went from that to a few networks connected to that. But in between kind of that and that, I don't know, I suppose there are a few thousand networks. They wanted to change the protocol to the internet protocol, which Bruce will talk about later. But getting people to switch from one protocol to another under a system that already has a few thousand connections is quite hard. They tried to have a deadline that here's when we're going to start, here's where we're going to end. They even turned off the old protocol in an attempt to get people to move over, but that still failed. It still took 3 months longer than they expected. So it kind of shows that even in the nascent stages of the internet, you were starting to have governance issues. So in summary, the internet really, it was technology. It was a bunch of technology geeks. It was what they would not call it governance, they would call it administration, management. They weren't really thinking about the security. They weren't thinking about economics, about social implications. But you can see even in that really, really niche area of very geeky technology, there were already issues with governance that we're seeing on a much larger scale now across the spectrum of issues. So does anyone have any questions? Because that's my section. Cool, so then it's on to Bruce. No, is it Bruce? Yes.
Thank you, Samantha. I'm conscious that I'm partly surrounded by internet experts in this room, so it feels a little odd to be talking about how the internet works. Thank you. So I guess as Samantha pointed out before, probably the main difference between internet and traditional phone networks was originally with phone nets you had a physical connector, it was actually a wire, and you connected it from one house to another. Then you had an exchange and you had a wire connected to that exchange. A number of people had wires connected to that exchange, and then someone basically got a little wire and connected the two wires together. So basically it was sort of fixed connections. The internet works very differently. It works very much more like a postal network. And so you put a label, just like you put a label on a letter, and you throw the letter into the system, and the system sort of routes that letter around the world. And so with IP addresses, initially it was fairly simple. There was a set of addresses, address format, and you can see that 216.58.216.164. Essentially that was an address that you would put on your envelope that you send into the network. Initially, address ranges were granted to telecommunications companies, universities, internet service providers. And in the early days, there wasn't that much demand, so there was no real issue with giving people quite large address ranges. It's like, oh, you can have 64,000 addresses if you want. No real scarcity. Then over time, as the internet started to take off, there then started to be scarcity. And what you started to see there is that North America, US predominantly, had a large number of these addresses, and they weren't really in any danger of running out. But the rest of the world, countries like China or India, where the populations are huge, the number of devices that can be connected becomes huge, suddenly they're going, wait a minute, you're no longer handing out these address ranges, and it's starting to make it hard. And that's when the sort of governance started to come into play. It's like, well, actually, we really should have a fairer way of allocating addresses, allocate addresses to particular regions, let those regions then allocate those addresses to organisations that needed them. And then the size of the address range then started to be a lot more proportional to what you need rather than what you want. So you couldn't just say, I want a massive address range. It's like, yeah, but you've only got 3 computers in your house. And so it shifted then to actually starting to ration, if you like, these addresses in a structured way. But even with that, yeah.
What year is this?
Oh, Paul could probably give when it started to, yeah.
And also what process someone would go through?
Oh, well, typically you would apply, so originally it came out of the US, and you would apply for an address range. Then it started to get regionalised. So APNIC, for example, was established in this region in about 1998, I think, 97, 98. First start 93, okay. And then you would apply regionally. And typically it was ISPs or telcos applying for the range. So they'd apply to the local, in this case, Paul Wilson here is the CEO of APNIC, which is the Asia Pacific region. Yeah.
If someone came from, let's say, Nigeria,
Yep.
got a ISP, how would you validate?
Well, what happened is that these regional groups, APNIC started fairly early, as Paul said, in the early 90s. More recently, there's been other regional internet registries created. One created in Africa. That would have been probably, I don't know, about 5 years ago, maybe 10 years ago, as to sort of meet the demand in those different regions. So if you're in Nigeria or some country in Africa, you would go to the African Network Information Centre to get the IP addresses. Yeah. The internet service provider would, yeah. And then when you're buying a service from an internet service provider, they're giving you an address from their range. Yeah, typically. Now, some companies that are quite large and running their own networks would have their own address range. generally, you know, like a bank or something that might be running its own network. But a typical, let's call it small business, is generally getting an internet address from their internet provider. Yeah. And then a number of things were used to deal with this scarcity. I can see we're going to get deep into IP addressing. Okay, yeah. Yeah. Yeah, well, the regional exchange is probably more to do with routing than IP addressing, yeah, which is, you know, where do you connect these different networks together, not so much who's issuing the address ranges, yeah. The other thing that started to emerge was techniques to try and make better use of these addresses. So what you find at a home network, for example, they are dynamic addresses. So when you connect, you get given an address, and when you disconnect and come back a week later, you can get another address. So it started to kind of get reuse, because in the early days, everyone would just be given a fixed address whether you used it or not. And so we started to ration and make better use of those addresses, which is typically what you get as a home user. You're getting a dynamic allocation of the address. And then we hit a point relatively recently where it wasn't possible to allocate any more big address ranges out of the IP version 4. There's a bit of a secondary market. You can actually, you know, purchase address ranges or reach agreement to transfer address ranges from one organisation to another. But the Internet Engineering Task Force then decided we need a new address range, which is much bigger, and that's referred to as IPv6. So it's a much bigger address range, and IPv6, because it's a huge address range, it's actually not a lot of contention to get allocated address space. You know, nobody's particularly worried about it today. It's like, oh, we've got so much. It's like IP version 4 in the late 1980s. So the focus is still probably around the fact that the IP address 4 range, a lot of older equipment, older routers, really only handle IP version 4. So if it's in countries that may be reusing or using old equipment, they would find it hard to use IPv6. And so there's still, you know, a lot of demand, if you like, for IP version 4 range, although certainly most modern devices that you'd buy off the shelf today will support IP6. Your laptops and computers that most people I can see around in this room, I'm not seeing any that look particularly old, so they'll be able to support IPv6 as well. The next topic, I guess, is routing, and this is probably the crux of how the internet works. I was trying to think, perhaps an analogy is it's a little bit like LinkedIn. So if you think about those of you that use LinkedIn, if you want to join that LinkedIn network, you can just start as an individual and say, I want to connect. And the first thing you typically do is you connect to someone. So you might go, I know that person, I'll connect to them. And that was kind of how the internet built up dynamically, because you could be a university, you could be a small business, you could be a large business, say, I want to be connected to the internet, and you pick something to connect to, and then you got the connection into the network. And with LinkedIn, you can actually see how to get to somebody else. So, for example, if you connected to me and I know Craig, and you wanted to get in touch with Craig, you have a choice. You could go through me, and I could actually pass a message on to Craig. Or once you kind of know where Craig is, you might then establish a connection yourself. And so the internet kind of built up. First, you didn't have to get permission from the government. You didn't have to get a license. All you had to do was find somebody that was already on the internet and connect to them. And that's how it's the diagrams that Samantha was picturing earlier. It's now massively connected, because I don't just have to connect to one person. Just like LinkedIn, I can say I'm going to connect to Craig, and I'm going to connect to Paul, and I'm going to connect to Alistair, and I start building up a series of network connections, and they in turn build up a series of network connections. And if you used to rely on reaching Craig through me, and I just was unavailable for some period of time, there's somebody else that's connected to Craig that you've subsequently connected to, and so now you can go that way to get to Craig. And that's where this sort of resilience from, whether it's nuclear attack or government attack or any kind of denial of service comes from, is because each of these internet connected nodes are connected to many other internet connected nodes. And if you remove one node out of that network, there's usually another way of getting to the destination you want to get to, so it's highly resilient. So routing protocols essentially are protocols that share information on how to find different addresses and different address ranges, and it's completely dynamic, very different to how, say, a postal network works in Australia, which is much more sort of top-down hierarchical. You know, to reach a particular state, you must go to this sort of head post office to then you have to go to this regional post office, and then the postie goes and delivers. And there's one postie that delivers the letters to you. Whereas the internet, there's thousands of posties that come and deliver mail to your letterbox every day. So highly resilient. If one of the posties is sick, there's another person that can come and deliver the same piece of mail to you. So that's kind of my layman's version of routing. So we've got this ability to address a letter with a number. We've got the ability to throw it into a network. It's highly reliable, and it will nearly always deliver that packet or that letter to the destination, even if one of the nodes is broken or breaks down. Then the problem came to be, well, how do I keep track of all these numbers? So in the early days, computers, it was very similar to the way people use mobile phones. So I'm sure pretty much everybody here has their own address book in their mobile phone. And in my mobile phone, I would have an address that says there's a person called Craig and there's a person called Paul in my mobile phone. Someone else might have a mobile phone and they have a Craig and a Paul, but they're not the same Craig and Paul. So what started to happen is people would start sharing address books, because you'd go, I don't know what all these IP addresses are. Can I have your address book? And you go, yeah, sure, here's what was called the host file. And it's a list of names and addresses. But then we started getting confusion here, because in my file I've got an entry called Craig and someone else has got an entry called Craig, and they're not the same thing. So the concept of the domain name system was to have a system where each of these names would be globally unique. And the idea was that it would start with a sort of a tree or a hierarchy, and this was basically developed by a person at one of the universities in California called John Postel. It's what would be a reasonable hierarchy? Well, I think we can divide predominantly the US into commercial, networkoperators.net, non-profit organisations.org, military.mil, education.edu, gov.gov, made it a fairly sensible hierarchy of names. And then said, well, also I'll start allocating names and making them available for countries. But he soon realised that trying to choose which name a country should have, especially when we're trying to use short abbreviations rather than full names, would start getting political. So, for example, Australia is AU, but AU could be Austria. There's other uses of the term AU. So who decides that? And he said, well, there's an existing international standard which actually came out of the postal system, where each country was given a 2-letter code, and he basically said, well, I'll use that, and if you want to argue which code you should have, then go to the International Standards Organisation and argue it there. I'll just use whatever's on that list. And so that's how he identified what 2-letter code should go with what country. And then he had to decide, well, who should run one of these countries? Well, in the early days, and this is back in the 90s, well, this was really just a cooperating network of individuals that tended to work at universities or government research institutions. Samantha mentioned the RFCs, which is where they would get together in an organisation called the Internet Engineering Task Force, come up with ideas, and they meet each other. And then, so when John was going, well, I think we should have someone who I trust who will operate in the best interests of Australia. Who do I know? I remember meeting a guy at a bar called Robert Ells. He seemed like a fairly nice fellow. He can have .au. Meet another guy from the UK, a British bloke. He seemed very British, so therefore that probably means he knows something about the UK and would likely operate on behalf of Britain. That was sort of Willie Black, and so on. He just gave it to a bunch of individuals around the world. And a lot of that still exists today. A lot of those individuals still are running the TLD that John initially allocated. But certainly in more developed countries, the communities then wanted to get involved and saying, well, it shouldn't just be one person that's in charge of this. It should come to some sort of infrastructure. And that's kind of how we started to get internet governance into the domain name system. The other thing that's changed since John Postel's days is we now have international characters, so you can have top-level names in Chinese, as an example on this slide. So it's China in the Chinese characters. And then at the end there, that's Russia in Cyrillic or the Russian alphabet. Instead of having a few, I'd say, probably less than 20 top-level names, we now have several thousand. And they can be organisations like the Australian Football League, and you can go to a website like play.afl. There are organisations like universities that have their own top-level names now, so you can have names like study.monash, and there's also Chinese and Cyrillic and various other character sets at the top levels now as well, so quite complicated. And then there's a hierarchy, and the concept of the hierarchy is that you're sort of basically in charge of all the layers below you. So we have an organisation that's in charge of .au, and they can delegate a name like CSIRO to the CSIRO, and then they can decide what names they want to have underneath that. So it's a hierarchy. I think that's about it. Over to you.
Let me just check. I'm not sure if this one's good. Okay, so picking up on where Bruce left off, I'm going to be talking a bit more about the policy side of the internet. So we've covered the technical aspect, a bit of history, and setting the scene for the governance of the internet and governance on the internet. So hopefully I can try and give a bit of a foundation of internet governance. But just to start out, can I get any ideas about what comes to mind when you think of the word governance? Does anyone have any particular any pictures that come to mind when you think of this? Rules? Yep. Processes? Yep. So voting? Yep. Anything else? Bureaucracy? Yeah, definitely. I think they're all really good things that I would think of as well, in terms of like government, maybe the courts or the White House, like really, really official and formal things, which are all formal governance systems. So this is, I guess, what most people think of when we mention the word governance. And I think it's something that actually can be a little bit of a deterrent when for newcomers in the field of internet governance, because we hear the word and we think, that's not me, that's done by someone else who's very important and probably has a bit more seniority. But governance is really more about how decisions are made and how society organises the processes that are behind making decisions. So I hope that through this section we can sort of show that governance on the internet is not the same as those kind of traditional governance systems where it's very top-down, maybe run by a government or some kind of senior management, an exclusive group, but governance is using nowadays something called the multi-stakeholder model, which actually is supposed to be inclusive and bringing in people from all the different groups of society to make sure that everyone is represented and they're at the table with an equal footing. So just to give some context on where the actual term internet governance came from, back in 2003, the UN created a forum called the WISES, which is, it stands for the World Summit on the Information Society. And that forum was more focused on using ICT for development, so focused on achieving the UN Sustainable Development Goals. And as part of that, they decided to, they couldn't really agree on where internet governance was going or what even the definition of internet governance was. So they decided to create a working group, which is very internet governance. There's so many working groups in different forums, but they created this new working group called the Working Group on Internet Governance to sort of try and develop a definition and work out what is actually in the scope of internet governance. So from that working group came a particular definition which has stuck around, it's stayed until today, and that is internet governance is the development and application by governments, the private sector and civil society in their respective roles of shared principles, norms, rules, decision-making procedures and programs that shape the evolution and use of the internet. So that's a bit of a mouthful, like there's a lot in that, and it's a lot more than just making decisions or It's more about processes as well, and it's really not just about the government. There's also other stakeholders there in that definition as well. So I want to just go over a little bit about the different layers in internet governance, because it is a big ecosystem. Yep. Oh yeah, sure.
What's the verb here? Is the whole thing a definition?
Yes, yep, that's the whole definition. So yeah, it has a lot of different parts. Sorry?
That's what internet governance is.
Yes. No, it doesn't. It's intentionally very broad, and it can be interpreted in different ways. But that definition has stuck around till today, and different groups have slightly different definitions, but that's kind of the broadest definition of internet governance. Perhaps some other people here might have other definitions that they sort of subscribe to. But the actual ecosystem itself is fairly large, and just to break it up into two broad categories, since the creation of the internet, we've seen governance of the internet, which includes sort of the internet infrastructure, policies and standards, more about the actual technical aspects of the internet. And there's a governance area which is about governance on the internet. So that's talking about the issues that the internet has created, issues that might have even existed before the internet, such as, crime or like human rights issues. Those kind of issues also exist on the internet as well, and perhaps in a slightly different way. And so some of the same stakeholders who were involved in those issues before the internet, such as law enforcement, for example, are now having to deal with different ways of deal with those issues in different ways on the internet itself. So there's a lot of information in that slide, but essentially there's a couple of different buckets of categories of governance in internet governance space, and different forums that deal with those kind of different issues, and spaces to talk about those things. So I'm going to talk a little bit more about each of those categories. So governance of the internet and on the internet. And governance of the internet talks a lot more about the technical administration and management of the internet, and also internet standards. So the technical administration and management includes things like IP addresses, the DNS system, and domain names, like what Bruce talked about before. So there's very specific organizations that manage these resources, and a lot of them, they have forums for people to come in and talk about the policies that should be used to govern the resources on the internet. So while they are organizations who are responsible for these resources, they have adopted this sort of multi-stakeholder model as well, to allow the average person to come along to their forums and analyze their policies. For example, I was able to go to one of the ICANN meetings in Japan earlier in the year and participate in some of the working groups on different DNS issues and the policies that are being created to actually govern the DNS system. There's also other organizations like APNIC who look at IP addressing and AS routing number management, and AuDA who are doing the .au domain administration. And there's a whole other suite of organizations who do internet standards. So the World Wide Web Consortium, for example, the IETF and ISO work more on how to make different internet standards, different internet protocols operate with each other in a global ecosystem. As every country has their own different laws and perhaps wants to implement the internet a slightly different way, but for us to all be able to talk to each other, we need to all understand the same technical standards and protocols. So I'll go into a bit more detail about the internet number management. So there's a group of 5 organizations called the Regional Internet Registries who work on the allocation of IP addressing and routing number allocations. So they're originally the US was sort of taking over this role, overseeing a lot of the resource allocation from a very top level view. Eventually, it's been broken up into different organisations distributed throughout the world, having different blocks of resources that they allocate just to their region. So for our region, APNIC is responsible for allocating like IPv4, IPv6 addresses, and the ISPs would then request those addresses from them, and then from there your organisation is able to get an IP address. So yeah, that's it's eventually filtered down into a much more distributed sort of ecosystem. And in domain name management, ICANN is the main body for looking after the DNS system and DNS policy. So there are a few stakeholders who are mainly responsible in this area. So ICANN, registries and registrars who allow the average person to actually buy a domain name. So does anyone here have their own domain name for their website? Yeah, so if you're one of those people, you probably have dealt with a registrar who's someone that actually sells domain names to consumers. And registries tend to be the owners of a top-level domain name, like .com, which is owned by VeriSign, for example. But these days, registries and registrars are increasingly becoming sort of the same organisations, and there's less difference between them these days. There's also root server operators. So in the ICANN ecosystem, there's a group called the Root Server Advisory Committee, and that consists of representatives from the 13 root server operators, and they essentially run the very top level servers that run the internet, run the DNS system, sorry. And there are 13 logical DNS servers, and they run the infrastructure that supports the top level DNS servers on the internet. So there's just a map of some of the logical root servers which are managed by those different organisations. And even though there's 13 logical servers, obviously there's a lot more. They use something called anycast routing to allow consumers to contact, or anyone to contact, the closest server to their geographic location. So I'll talk a bit, in the interest of time, I'll talk pretty quickly through governance on the internet, but I think there might be some interesting questions, particularly about internet issues. Governance on the internet is more to do with issues predating the internet. So, for example, crime, human rights, privacy, things like that existed before the internet, and the internet has changed the way that these issues have kind of propagated in society. Criminals obviously are quick to identify gaps and exploit the internet in different ways. And it creates new issues like cross-border approaches to addressing issues like, like trafficking drugs or illicit materials. Because it requires more of a cooperative approach between different countries in actually addressing issues rather than just sort of this siloed old hierarchical approach. And there's just a few issues, internet issues, some of which are affecting Australia as well. For example, like internet access, diversity and inclusion in the online space, like who has a voice, who's able to be heard, and what kind of rights do we have online? Do the same rights exist online that we have in the physical space as well? So it's a really complex area. And something that's really interesting is that with the advent of internationalized domain names, there's a lot of work being done to make the internet at its core more accessible, so that people can access the internet in a language that they understand, not just like an English domain name. ICANN is there's a working group on universal acceptance, which will allow the use of more domain names in different languages. So like you could have a domain name registered in Chinese or Russian or whatever language you speak, which allows people who don't understand English to register a domain name and have a business in their local country. And yeah, it's just another step to make it more easy to use. So I'll just finish off sharing a bit of my experience at a forum called the Internet Governance Forum, which is my first contact with Internet governance. The Internet Governance Forum is an annual forum that brings different stakeholders together from the community to basically talk about internet issues, talk about technology, policy, all kinds of different things. And it's a really inclusive, and it's probably one of the biggest internet governance events that takes place globally. So I participated in 2017 as a fellow through Internet Society, and had the chance to attend a lot of working groups and forums on cybersecurity, which is an area I'm really interested in, and just talk to some really interesting people from around the world on what they're doing in internet governance and technology. So if you have a chance to attend this forum, I would really recommend it, and all the sessions are also recorded online. And they allow remote participation as well. So Helena also attended as well, and we both had the chance. This was our first our first entry into internet governance. Didn't know what we were getting ourselves into, and I guess we had a session similar to this, which introduced us to all these basic concepts and what this community is, which is why I'm here today, and why I'm helping to run this event as well. So I'm going to hand over back to Bruce to sort of talk a bit more about the Australian internet governance ecosystem.
Thanks, Bronwyn. I'm going to push the go button there. So I guess the Australian internet governance system, as Bronwyn mentioned earlier, internet governance is intended to have government involvement, involvement from industry that are running infrastructure, involvement from the technical community, civil society, universities, and also organisations that I guess oversee parts of the infrastructure. If we look at the government piece, the Department of Communications has a fairly broad remit. They tend to focus on telecommunications companies, and there are some laws. There's a telecommunications legislation that defines various regulations with respect to telcos. There's far less regulation for organisations that host content, so web hosting companies, and they're pretty much very little regulation there. The Department of Foreign Affairs is obviously looking at, in the region, how does it improve cooperation, particularly around things like cybersecurity. The Digital Transformation Agency, DTA, basically administers gov.au for governments. So the internet's really across a number of departments. You could add more here. There's Department of Home Affairs. They're obviously looking at security and terrorism sort of usage of the internet. You have Attorney General. So each sort of government department looks at their niche area, and there's often legislation that's created for their niche area, not necessarily coordinated across the different government departments. The other thing you'll see in Australia is we have not as many organisations. If I look at I was looking at the history of this actually, so going back 15 years ago, there's probably 10 organisations that internet service providers and others used to be members of. That's pretty much collapsed, and I think part of it has collapsed because of network consolidation. So in the early days of the internet, there were literally thousands of internet service providers. Now it's tended to consolidate. There's sort of 5 or so which are aligned with telcos, so the Telstras, the Optuses, the TPG Telecom, that pretty much operate most of the infrastructure, and they're big enough that they can employ full-time staff to lobby the government, so they don't really see a need to really have some community organisation anymore, and so those organisations have disappeared. The two that are left, there's Internet Australia, which is mostly, I guess, interested end users that have been involved in the internet since the early days, and that's I think there's a pretty low joining fee for that. I'm sure it's less than it's probably $20, something like that, but anyone can join that. And Electronic Frontiers Australia, I don't know what the membership fee is, but I'm assuming it's not high. They're sort of looking at sort of freedom of speech aspects, and they write submissions on government policy to ensure that freedoms are maintained. The IP Address and Domain Administrator, so IP Address Administrator, APNIC, it's regional focus, although it's physically based in Brisbane. You can join APNIC. The fee If you just wanted to join without running any infrastructure, I think it's around about $500. And there are higher fees depending on how much address range that you manage. Typically, APNIC's oriented towards network operators. So it's generally network operators that join, but those network operators can be at telco size, like Telstra, but they can also be very small. And you can run your own network in your own house and join APNIC and have a small address range. So it is fairly broad. And because the types of network operators are very broad, there's governments, there's large telcos, there's corporations, there's non-profit organisations, there's universities, there is small businesses. So the membership of APNIC is pretty broad, but the concept is that they're running some sort of infrastructure. The AuDA, the .au administrator, is focused on names policy. It turns out that people are much more concerned about what name they get as a domain name versus what IP address they get. You don't hear people saying, well, my business, my IP address ends in a 3. I really wanted a 2, Can I get a better number? It's not really a focus. Whereas names is very different. Names, the typical scenario we get at AuDA is someone else has got my name. My name is this, and someone else has got it, and I want it, because I should have control of that name. So people care a lot about names, and they like to be the person that's owning the name that they choose. And hence the policy around names is far more political. It involves a lot more interests, and in the early days when AuDA was first set up, in about 1997, and it was called the Australian Domain Administration, I think. It was just internet service providers that were predominantly members. But it rapidly became apparent that people sort of thought, well, it's not the internet service provider that should choose what name it is, I should choose what name it is. And you had intellectual property people that owned trademarks, they wanted names. Individuals wanted names, organisations wanted names. So AuDA itself has become much more of that sort of broad internet ecosystem that you see up there. It's free to join. You can go to joinauda.org.au today and join for free. So it's very open. There's about 1,500 members currently. And the only requirement to be a member is that you need to have an Australian presence. So you either need to be a citizen or a permanent resident, have a company in Australia, or if you're a foreign company, you need a trademark in Australia. So you have to be connected to Australia. That's probably about it in the internet governance system in Australia.
Yeah, that's it. Does anyone have any questions?
We've obviously got China doing their own thing to some degree. We've got Russia doing their own thing to some degree. We've got Iran doing their own thing to some degree. So what's the kind of international picture, I guess, of... We've got this internationalist organisation, kind of like the UN of the internet almost, or various UNs, but in fact related to the UN. But we've also got this fragmentation occurring. So I'm just interested in, what people's view is, I guess, on that.
So that's interesting. So you have the UN, but then you have the national sovereignty of states. So that's how governments rationalise the fact that often they're doing something separately within their state as opposed to the collective global agreements that are being made. So you'll hear a lot at meetings talking about you have to respect our national sovereignty, however they wish to interpret it. Yep. Well, you've got the halal internet in Iran that they've been developing. You've had Russia in the past week deciding to test their internal national non-connected internet. So, yeah, there are those efforts.
I'm Paul from APNIC. I mean, fragmentation can happen at different layers from the applications all the way down, and fragmentation of applications exists, right? Facebook is not compatible with other social networks in an interoperable way. We are all sick of using 10 different instant messenger applications, right? That's fragmentation. the fragmentation at the infrastructure layer, which would actually create fundamentally separate internets, actually isn't happening at a fundamental level. We still have global networking and globally unique addressing being administered across the internet, which is, for the time being, it's the way things are and should be. So what's happening in China, for instance, is that what they call the Great Firewall, which is a set of equipment that sits at the Chinese border and monitors and stops and actually alters traffic at a layer above that infrastructure. So fortunately, at the moment, there is not an actual separation of the fundamental infrastructure, which would kind of become irreversible if it was to emerge. And I think the Chinese government and others are probably smart enough actually not to allow that to emerge, because it is irreversible. Once you've actually started to number a whole network infrastructure, it doesn't need to be anything like as huge as China's is. But once you start to number it independently, the chance of reversing that and actually sort of reverse engineering compatibility with the rest of the internet is very, very slim. So I think when that fragmentation is possible, sort of at the layer above the infrastructure, that's where it's being done. And although China is a notorious example, there's very few countries, including our own, that don't fragment, that don't filter, that don't impose some sort of boundaries, firewalls at the boundary. Bruce mentioned APNIC membership. APNIC is member funded, and you only get access to the APNIC allocation services as a member, but everything else is kind of open. So participation in APNIC as a member of the community is free for anyone who wants to rock up or subscribe to mailing lists or whatever. Thanks.
There's multiple low Earth orbit satellite services going up at the moment. Amazon, SpaceX, and I think there's a couple of others that potentially will blanket the whole Earth in another ISP. How is that what's the governance for something in space, and will that break the Great Wall of China and Great Firewall of China?
Well, those networks can be individual ISPs, or they can be like the NBN, which actually is a transport network that allows multiple ISPs to operate on top. So technically speaking, it could be one or it could be multiple networks. The governance is in the hands of some aspects of governance are in the hands of the ITU radio communications area, which deals with satellites. But it's quite true that that those satellites are going to be accessible in China to anyone who's got the equipment, who's got the courage to use the equipment against what's probably laws against it. But yeah, it's quite right. Those and existing satellite systems that have footprints over any part of the planet can't exactly be blocked, or maybe there's terrestrial blocking, radio frequency blocking that can happen, but I think it's yet to be seen.
I guess one observation on that point is...
We're about to break for morning tea, so we'll just have one more question.
Okay. Hi. My name is Dennis, one of the students at UTS. Just to ask a quick question. So every time standard or policy is raised, especially not just the internet, even going into IoT devices and everything, coming to security. So, for example, in IoT, the SB 327 went through for California only, and people are complaining that it's nowhere technical enough to be even useful. So what is the government up to this? Every time the standard comes out, everyone complains that it's not technical enough. It's not meeting certain level it should be meeting. So is there any, things that government's doing to really meet that requirement? Or if you do want to raise a policy, is there anything?
Is that specific to IoT, that your question, or is it
even the internet? When I looked up, the Mitra had a paper about even the technical standard for the internet is not sufficient enough.
I think the great thing about some of the internet standards organisations is they're actually pretty open open to anyone to participate. So, for example, the IETF, which develops a lot of the standards, most of the standards for the internet, they allow anyone to come along and join. So if you have an issue with the internet standards, you can actually sign up to their working groups, sign up to their mailing lists, and just start participating. They used to have a lot of fellowships for newcomers to attend the IETF, but as far as I'm aware, the easiest way to get involved is through the mailing lists. So a lot of stuff is done just through mailing lists. Yeah.
My name is Silvia Cadena. I am one of the members of the multi-stakeholder group that manages the program for the Global IGF. So just wanted to make a comment about some of the words that Ian Peter raised in the initial session about the importance of collaboration. In some of the comments that people have made in the room is about basically one stakeholder group of one type of knowledge or experience or how you see the internet colliding with someone else's, right? It could be China, it could be the IoT, it could be technical, it could be human, it could be social. The important part of these processes is to be open to that dialogue and to be open to share the knowledge that you all have in all your different stakeholder groups, in the areas where you participate, in your areas of influence. The very big challenge on all of this is to pretend or to think that the technology will suit and will fit all of those problems. Suddenly there will be a protocol or will be a button that we will push and then it will be solved. And that the reality is that it's not. It is a challenge as the nature of humans to actually find these solutions together. So a lot of the policies and a lot of the standards and a lot of the issues that we see with new technologies that are coming to the internet are actually because people that see the big monster in the room thinking, oh, this might be a problem with X, Y, and Z, have never sat together to talk about what's going on. So it's although I understand that when someone tells you or tells us, join the working group or sign up for the mailing list, have your voice heard, sounds like, really, maybe not have the time, or I'm doing this or I'm doing that and I can't. Please volunteer and get involved, especially from so far away from the rest of the planet like Australia is. Australia is very innovative. It has managed, as a Colombian living here for the last decade, has managed to make a lot of innovations and change the world in many different ways. You can still do it, so get more involved. It's pretty sad to see the participation of the Australian delegation in these global events getting smaller and smaller and smaller. Fellowships are an issue and travel support is an issue, but if you are good enough, people will support you. So get engaged and participate in these conversations, because it's actually a collective understanding that will help us through this hump of where we are.
That's an interesting claim or comment about standards not being technical enough or not being good enough. There's different standards bodies and they work in different ways, and the IETF has got a famous credo, which is one of rough consensus and running code. The second part, running code, means that nothing gets standardised in the IETF unless it is actually implemented and runnable. And in fact, as Samantha said before, there are very few official internet standards. Even IPv6, I think, is still not an internet standard because it's not up to that completely bulletproof stage of a review, I guess. But there are literally thousands of different ad hoc demonstrated standards which are being used. And so to say that they're not technical enough or not sufficient kind of doesn't stack up when they're actually in use and running. The ones that you might have a criticism of are those that don't follow that credo, and where you have a standard that has got no implementation or no implementation plan, and there have been plenty of those as well. So, famously there was the ISO standards back in OSI standards back in the early days of the internet, which failed completely because they were theoretical standards which had no implementation at all. So an extremely complex set of standards, but not implemented.
All the best standards you can think of have reference implementations. You'd actually be surprised, like JPEG, MPEG,
Right.
applications, pretty much, that you can actually these days do a pull request on it, and they're not that hard to find. So if you want to contribute to the referencing limitations, in a lot of areas of my algorithm I need a streaming side, but you'd be surprised how strongly
I haven't quite finished.
Public domain, and you can definitely contribute to them if you want to improve them.
I would just also caution you to be very careful about claims that standards aren't good enough or aren't there, particularly when they're working, because you're always welcome to propose additions or alterations if you like. But people criticise the internet for not having security. That's actually a design feature that the internet itself, at the internet layer, doesn't have security. So to say that it needs security is kind of a flawed argument. But it's one that gives you an opportunity to make up the security model that you want to propose and take it into the IETF. So beware of those claims as well. Well, exactly, yeah. IPv9, if you like.
Thank you for your questions and for attending the session today. I think that I wish we had more time for discussion. Next year we'll probably allocate more time, but it's morning tea time now. I think perhaps until... I don't think it's... Oh, yeah, maybe until 12. So the next session starts at 12. So please go and grab yourself a coffee and have a discussion outside.